All right. Well, good morning, good afternoon, and good evening to everybody out there in YouTube land. Welcome to Season 4, Episode 1 of the 2026 Java Champions Conference. It's been quite the last few days with a lot of great talks, and today is the last day. I'm happy to be moderating Frank Delport's presentation on the foreign function and memory API. And just wanted to, one programming note here, we're going to save all the questions until the end. We'll mark them so I can look at them near the end of the talk and then display them on the screen. So, let me introduce Frank. So Frank is a Java champion. He is the author of Getting Started with Java on Raspberry Pi. He's a senior technical writer at Azul. And let's see, he's a blogger on webtechie.be and fuj.io. That's right. I see your posts all the time there, right? Let's see, and contributor to pi4j.com. Frank blogs about his experience or experiments with Java, sometimes combined with electronic components on the Raspberry Pi. So, without further ado, Frank, take it away.
Okay, thanks a lot for the introduction. And that means I don't need to introduce myself anymore. Very good. So I'm going to talk about the FFM API in Raspberry Pi in the Pi4j project. I will share a lot of links where you can read more and find more information, but all the links are already on my website. So if you go to webtechie.be, you can find all the links mentioned in this talk here below. So you can just follow the presentation and check the links later. What this talk is about is actually this kind of code. I don't know if you understand what's happening here in this short piece of code. I actually don't, which is really a pity because it's code taken from the Pi4j project. And the Pi4j project is a library, a Java library, to interact with electronic components connected to the GPIOs of a Raspberry Pi. That means that they are connected to those small pins here on top of the Raspberry Pi. And this code, this library, contains a lot of native libraries. So it wants to help Java developers to make it as easy as possible to interact with these electronic components. And that means that under the hoods, there is a lot of native calls to be able to talk to these electronic components. And until now, this has been very complex within this project and also in other projects, and that's where the FFM API wants to bring improvements. So the FFM API, the Foreign Function and Memory API, it's an API developed within Java, the JDK, the JVM, to provide memory safety so that you can safely access off-heap memory. There are already ways to do that, but they want to provide a better way. Native interoperability so that you can seamlessly integrate native libraries without the JNI complexity. JNI, we will come back to that later. And with high performance, so that JNI, which already exists for quite some time, it works very well. So the FFM API should at least be as good or even better if possible. Who am I? Yeah, you already heard the story. You can find me on all social media. I love to use, write, and talk about Java and JavaFX. And I'm a senior technical writer at Azul. And a disclaimer, I'm not a contributor to FFM. I'm even not an expert, totally not. I'm just sharing here what I've learned by experimenting and following what happens in Java releases, because that's part of my talk, is how this FFM API project came along. And as mentioned before, I've written the book Getting Started with Java on the Raspberry Pi. I will publish a new version very shortly, in a very short time, because there are a lot of changes. Java 25 is already available in the ebook, the updates of last year, but there will be a new update with the new FFM API version of Pi4j. We had last year 30 years of Java. So it all started in 1995. My history with Java started actually around 2010. So with the move to Java 7 and 8 very slowly, because we had those big intervals in between. But what we see is that from Java 9 on, that we had this 6-month release cycle. And that's an important story to tell and to show you here, because it's also related to how the FFM API got implemented into Java. Now, if you're interested in how Java actually started 30 years ago, as mentioned already also, I write and create blog posts and podcasts for fujay.io, the website for Friends of OpenJDK. And I published last year a podcast with James Gosling, the creator of Java, about how it all started, but also how the Java world evolved and how he now looks back at some decisions and what has happened to the Java project. As I said, how Java evolves is an important thing if you want to understand how the FFM API was implemented. So I all invite you to visit the GitHub project, where you can find the source of the language that you are using daily. So it's not only the source of the language, the Java language, but it's also the source of the GVM, the virtual machine, the runtime on which we run our Java applications. So if you go look into the JDK project, this is actually the source of all we are using. A very short README, which is a bit strange for this massive project, but as the sources are available here, that means you can also download it, the current version, so with the last commit 36 minutes ago, and you can build this Java runtime, and then you will have the newest version, which is not available yet, like 26 will become available in March, 27 in September, I think. So you can already get those versions here. You can even build that on a Raspberry Pi. I did that quite some time ago, and at that time, I think I was using, it's somewhere here, I was using Java 14, but I was already experimenting, 16 internal. I was already building the 16 version of Java, which was not available yet, but I could build it on a Raspberry Pi and run it on there. So if you're really interested in how Java evolves, and want to experiment with the latest version, then you can just find it on GitHub. Funny note, another blog post I wrote is we almost missed a plane in Kazakhstan in the summer of 24 because I didn't, although I write the release notes of the Azul builds of OpenJDK, I missed this specific change of a time zone change in Kazakhstan, which is reflected in the sources of the OpenJDK project. All the time zone data is there. So if I would have followed the release notes better myself and the changes in OpenJDK, I would have known that. But the important thing is here, OpenJDK projects. So big changes in Java happen within projects. And the FFM API is a result of Project Panama. So you can find on the OpenJDK website, which has probably the most outdated UI of all websites that you can find about Java. But here you can find projects. What is happening? What are the big changes that people are working on to make Java the language and Java the runtime evolve? And Project Panama is only one of them. You can see that there are a lot of different projects. And everything which happens in these projects, you can follow that on a mailing list, for instance, so you can really know what's happening, what people are working on, how they decide how they will implement something, for instance. So all that happens within projects. And then the JEPs are actually the results of projects. So at a certain point, they decide, yeah, we have something which is finished, we know how we're going to do this, let's implement it and make it available in the next release of Java. So it becomes a JEP, a JDK enhancement proposal. And here, these are actually very fun to read because they contain a lot of information. If I can find one directly of the FFM API, it was probably 448. No. Doesn't matter, I just take one. Here we can see why something is selected as this is something we want to implement. Also code changes of what is available now and what will be available after this JEP has been implemented and so on. So a lot of technical background info. So if you're really interested in what is happening in OpenJDK, please check these JEPs and these projects. And then a last thing you should know about these JEPs is incubator and preview features. So some of these JEPs, most of these JEPs even, are not finalized. They are integrated in OpenJDK as an incubator or a preview feature. And that means that the creators of it, the developers of OpenJDK, they want the feedback of the community. How are you going to use this? Did we implement it in a way that is the right way for you to use it? Don't we break something else in a related functionality? So if you want to use these incubator or preview features, then you have to enable a preview flag in your runtime during compilation and during runtime. IntelliJ, for instance, helps you to do that. So you really have to define, I want to use these preview features. They are not enabled by default when they are released. Okay. So if you look into Project Panama on what happened there, so Project Panama, the goal of it is to improve and enrich the connections between the Java virtual machine and well-defined but foreign non-Java APIs, including many interfaces commonly used by C programmers. So when they started Project Panama 2014, more than 10 years ago, they were thinking about how can we better integrate C libraries and C code into Java, which is now a very hot topic because machine learning, LLMs, all these kind of applications are available as C libraries, C programs. So it is a hot topic now because Project Panama, next to the demo I will show you with Raspberry Pi and Pi4j, has a lot of use cases in what is currently evolving in the software world. So they also want to provide an API that offers statically typed pure Java access to native code, replacing JNI with a superior pure Java development model. So why do they want to replace JNI? And I want to quote my colleague Simon Ritter, who says, I can't remember who it was, but I was talking to one of the engineers back in the Sundays and expressing my frustration with JNI being hard to use. And that's when he said it had been developed that way to encourage people not to use it. And why didn't they want people to use it? Because they implemented something which was asked for, but they didn't think it was a good idea. And they didn't want to integrate it even further in the JDK. So it is available, but it's really hard to use, but you can do amazing things with it. So JNI, we already have it since JDK 1.1, 1997. It's integrated in the OpenJDK, so it means you don't need dependencies to use it. The same for FFM, so it is implemented in OpenJDK. There were some dependencies in between that, like JNI and JNR, that you could use to make it simpler to use JNI. All these acronyms, they're very hard to pronounce, but they were easier to use, but then decreased performance, or they had some runtime safety things. So it was not ideal. And that's all the things that FFM wants to improve. And it actually did that. It delivered on all the things that it has promised. So if you look at Project Panama, it started in 2014. Then they were starting about how are we going to replace the JNI? How are we going to do it better? So they worked for several years on basic implementations, a proof of concepts, some tests, and actually they started delivering here with JEP 370. And these were only about the foreign memory. So how can we access memory more in a different way outside of the garbage collector and of the memory being used, managed by the GVM. Then they also had the foreign linker API. How are we going to link C libraries or external libraries to Java in a better way? And then you had the combination of these two in the foreign function and memory API, the thing that we really wanted. Again, 6 JEPs. So all these JEPs were incubator and preview features. So they were available in OpenJDK, I think from 14 on, but it was only in JDK 22 that we had green light, and it became a really implemented feature, ready to be used, stable, and just part of the OpenJDK release. So if you go through all these JEPs, so in 14 we had the first JEP, incubators, then another incubator, then more incubators, then 3 previews. Then a preview is, this is actually something we think is ready. Now, can you please use it and give us feedback? But they had 3 previews. So apparently after the first one, they were not fully happy. And so they went on. And then in OpenJDK 22, it was released. So people who claim that Java evolutions are slow, they are maybe referring to this. But on the other hand, by doing it in this way, the architects behind the whole OpenJDK, so both the language and the runtime, make sure that they don't introduce breaking changes, that the Java applications are still compatible with newer versions, but they also keep an eye on other projects, so that this project Panama is not interfering with things which will come in the future in Project Leiden and all these other projects we have going on, like Project Babylon, which I think will make it possible to run Java code on GPUs, for instance. They all have some kind of relationship, so they want to make sure that all these changes happen in a good way and that they are ready for the future, that if they start implementing other things, that they can use what happened in another project. So maybe it's slow, maybe this could go faster, but on the other hand, it makes sure that we have something which is stable, which is very important. Java, as I said a few times before, Java is boring, but is boring in the good way. I want my Java runtime tomorrow to act exactly the same as my runtime yesterday. And that's what happens here. Something to mention here is JExtract. JExtract is also part of this, but it's not included in OpenJDK. JExtract is a tool to help you to integrate complex C libraries with a lot of functions into a Java project. So you don't need it to use the foreign function and memory API. It's a tool to help you. Check it out if you want to know more. For completeness, within Project Panama, Vector API is also happening. The Vector API, again, started a long time ago and now becomes more and more important for everything related to LLMs and machine learning and all that AI stuff. It was not envisioned because they could not think so many years ago how all these things would evolve now very fast, but the Vector API is there. It's already in incubator for a long time, and it will stay in incubator for a few more releases, because this is one of those evolutions which is related to a lot of other projects. Cannot remember exactly which ones now at this moment, but so they will finish it together with other things. So expect it in 27, 28. We will see. It's actually ready. It's I think it's the JVector database uses it already since Java 16, because it's something they really wanted. But from time to time they have to change something because the API evolves. So it's not stable yet, but you can use it. It's integrated in OpenJDK. I want to show you a few small examples of how this code now looks like. So if I go into this thing, so don't mind the red here in this code, because I'm using, actually this is inside my project where I have my presentation, so nothing is configured correctly. But what I do here, this is a demo of the memory management and how you can access memory now with this FFM API. So what I can do here is ask for an arena. An arena manages memory outside of the garbage collector. So it's still managed by your GVM, but it will not be garbage collected. So there will not be any overhead added by the Java runtime that tries to manage it. Actually, you have to manage it. We can ask for a memory segment. So in this case, we need a segment that can hold 5 integers. And then we get an address. So this is the memory address where we have those 5 integer locations. And in this case, I'm just writing something to memory, random values, and reading them back. So no rocket science, a very simple application, but the goal is here, how can I write something into memory with FFM API? So these are all pure Java APIs. By the way, this is Java 25, so I'm jumping from 22, where the FFM API was introduced, to Java 25, where I can also use the simplified main method and this IO instead of system out print line. So you have this IO here, and you see I even don't have any imports. So I can just execute this code. I'm not going to show you any rocket science code here, very simple examples, but you just see, so we have written these values to memory and we can read them out again, same values as we expect. A very simple example. Let me go to another one, and actually, so all these codes, by the way, are also available via the blog post on webtechie.be, so they're also linked there. In this example, it has 3 examples of how to use a native library. I'm only going to show you one, which is a string length. So this is probably the most complex implementation you can do to get the length of a string. I know there is a Java function for that, but I want to show you how you could do this with the FFM API. So let's go to that function. So what we want to do here is find a native application, a native call we can do, which gives us a string length. So here we have the linker, one of those first JEPs that we've seen. And we also need to describe how this library works. So we know that it returns a long value, and it expects an address, a memory address of the string it has to check for the length. And then we have this function that we define here. So again, we have this description and we have where the library is found. Then we create a piece of memory in which we put this string. This gives us an address that we can use. So here we can actually call this method. So I know this is a lot of going back and forth, but it actually, this is pure Java code using a C library or a C method. And this is readable. If you compare this to the first code that I started with, which is an interface somewhere in between Java code and the actual library being called that you need to generate, here this is something which you can read, which you can, we as Java developers understand, we can follow this flow. So if I execute this, then it says that this is 14 characters long. I know I can do this differently with Java, but this is how you can do this with a native library. If you have another native library that you know that you want to use, I was talking with someone who has a history in mathematics, and he has some very nice mathematics libraries to do very complex calculations. He doesn't want to reprogram them in Java, but he wants to use them in Java. And that's exactly what you can do with this type of code. There are more examples here. Another one is comparing byte buffers, how you store a buffered image versus something in memory. And if I compare the same functionality implemented on the left, the Java 11 way with the buffered image, and on the right with a memory segment, which is writing data directly into memory. So what I want to do here is generate some gradients and move them 1 pixel. Then you can see that the same codes running on Java 11 versus Java 25, on the right, it has an interval of 5 milliseconds. On the right, 50 and more. So it's 10 times more efficient to do this with the Java 25 way. So all this code is available on the blog post. Now, mentioned a few times Py4j. What does it bring to the Py4j project? So if you look into that same graph, then you have this black box here in the middle. And that's where those implementations live, which are a bridge between Java and the native libraries. And these are very complex. What we've seen in the Py4j history, we had to adapt a few times. These libraries, these black boxes, they had to change. So we had to add a new plugin, restructure this, rework the code. Then we had the Raspberry Pi 5, which has a new chip to interact with GPIOs. We needed a complete different implementation, so back to the drawing board. But now all this will probably change thanks to FFM API and Java 25. So the new version that we want to release, well, actually wanted to release in December, we're now polishing the latest tests. So I hope we can do this in the next weeks. Version 4 will bump Py4j to Java 25 as the minimal version and have a plugin based on FFM API. So that same black box, you see it here on this diagram. That's where plugins get plugged in to interact with the GPIOs and use some kind of native libraries. Now, the code of Py4j is of course available on GitHub, but let me bring you to the project. And what we see here is, so this project is structured as libraries. This is where the native code is managed. And then you have plugins. And the plugins is actually the Java implementation of how we interact with all these different types of communications. Now you see the FFM is a new one, which was introduced. We worked on it in the last year, mainly Digital Smile. You can find them on GitHub, of course. So all this code exists here. But you see the other plugins, they all have a part also here in the libraries. And if you look into these libraries, what happens there is you see some native things. So we have C code here. Things I don't understand. I'm not a C code C developer. We also have Docker scripts to make sure that we have the right compiled version of a library that we can use it in our project. And we have Java code here. And this Java code is actually this kind of things. I can read it, I can understand it. I have no idea what it does. It's too many layers in between. And that's the fun thing with this FFM plugin. This FFM plugin is only here. We don't need this complex Docker things and these compilations. It's just a Java project. So the idea is even that we may go further with the Py4j project and move these previously used plugins, so all these, that we can just remove them, remove the libraries, meaning that our whole build flow would become simpler. No more Dockers, no more in-between steps to build the whole thing. So that's the dream of Py4j, that we can make this whole project a lot simpler. This whole implementation is based on this project, so Digital Smile. Digital Smile is Nick, who has created this project. I found it by accident. He has this Java 22 plus library for interacting with GPIOs and hardware interface. I reached out to him, can we reuse your code for Py4j? And he said, I have even a better idea. I will contribute it myself and make it even better. And that's what he has been doing now, the last, I think, 6 months or even more. He became part of the Py4j team. Py4j is an open source project, but we have quite a few core contributors who are really maintaining this project. I'm mainly there for the documentation and testing, but several very good engineers who are writing a lot of code that are way above my league, and I'm very proud of what they contribute to this project. But if you look at the very first pull request to bring this into Py4j, then you see that it was quite a big pull request. But this is something which we are now fine-tuning. Final tests I was hoping to release last week, but we found some things we want to fix still. So the plugin I showed you. So what we actually achieve with this FFM approach is like libgpiod, one of the already available plugins in the Py4j project. So you have Java code. This Java code calls JNI code. This calls a JNI wrapped SO. So this is generated with Docker. Then we have the native library. And then we actually do the system calls. Now with the FFM API, we just go directly from our Java code to those GPIO kernel system calls. So these layers are completely removed. So that means that we have less code, more efficient behavior, much easier to test and to implement and to debug. And if you look at the performance, again, it should be a big surprise that less code, less steps in between should be performant. So this is a benchmark, starting an application, reading an input and exiting. So this happens almost 100 times faster for the simplest case, up to 10 times faster or a bit better. But as they wanted to achieve at least the same performance as with JNI, they did manage to do that. By the way, this Linux FS test, which is has a lot, needs a lot more time. This is because we're actually calling the file system, so that's even a few levels higher. On an SPI benchmark, the results are not that different, but still it is faster. So also there we see that achieving a fast response is succeeded there. So what will soon be available is the release of version 4. So with this FFM plugin of Py4j. And then another project that I'm pretty proud of is, and that's why I love open source. So we have quite some users of the Py4j library. We can see that on the number of downloads. But from time to time, we have people passing by, connecting on Slack, wherever, and saying, yeah, I have an idea, I want to contribute something. It's like, I need to put it on a blog post like gRPC or GPC. I don't know. One of those communication protocols, there is an implementation now for Py4j so that you can interact API-wise with the library. But this one, contributed by Stefan and others. I don't know if I can see that here, but never mind. So what this project will do, this drivers library, will make it easier to interact with more complex components. Like, I don't know if they are added here as a list. So what they, for instance, want to provide here is an easy way to interact with displays, with hats, like you have hats for Raspberry Pi, which act as a joystick where you have several buttons. So hats like that, input-output devices, sensors. So all the extra things you have to do to configure a sensor to be able to use it will be handled by this library. And as we want to now first focus on the version 4 release, that's what we are focusing on, so that will come first. But then drivers library will also be released separately from the Py4j library itself. And we will do some blog posts and live streams and follow the project, and you will be notified when these will become available. And then another thing which happened very recently is because the FFM plugin in Py4j doesn't call any Raspberry Pi specific libraries, but just the Linux kernel, which is available since a few versions of Linux ago. So most of this functionality exists in any Linux distribution. So that means that you don't need to be on the Raspberry Pi operating system to use this new functionality provided by the FFM plugin. So I reached out to several suppliers if I could get a board which is similar to Raspberry Pi, and I now have a full stack of it. So this is, for instance, an Orange Pi, which is very similar to the Raspberry Pi 5. But I also have, and this is something completely new for me, a RISC-V. So a RISC-V processor, so not an ARM processor, not an x86 processor, but a RISC-V processor. This also runs Ubuntu. So that means that our FFM plugin should also work on this with this system. BeagleBoard, also a competitor of Raspberry Pi. They also built this kind of tiny PCs with ARM processors, with RISC-V processors. I also have this Latte Panda IOTA, which is an x86 board. So a lot of these boards should be compatible in one way or another with Pi4J and the FFM plugin. So this opens a new market, let's say, of where you can use Java to run on very cheap single board computers. And that is my goal for 2026, is to experiment with all of these. And if you go to my website again, then you will see that I actually already started with these. So I have my first test of Java on the Vision 5. I have it on the Orange Pi. The Latte Panda should also be here somewhere, but that's already from December. So the Latte Panda. So all these experiments are here. Not yet with Pi4J, but like for instance, JavaFX works on the Latte Panda IOTA. It's an x86. It also works on, where did I test it on? On the Orange Pi with the ARM processor. You can also run Java and JavaFX there. JavaFX, by the way, on RISC-V, that's something which is not there yet. But a lot of interesting things I'm experimenting with, and I want to see how far I can push this. And keep an eye on my blog, website, video channel, whatever. Okay, I want to show you something. The Raspberry Pi that I will be using is mounted into a CrowPi. So it's here behind me for the people watching the video. There. Okay. So this is the CrowPi 3. I also have the 1 and 2. So this is a case for people who want to experiment with Raspberry Pi and electronics. So you connect a Raspberry Pi of your choice in there, and then you can start using these sensors and devices. The board, Raspberry Pi and CrowPi, are designed for Python. They come with Python examples, but of course we want to do that. I have to update a few of these links. We want to do that with Java, of course. This project is now archived, but actually we have a project here, which is now maintained by the FHNW University from Switzerland, with all implementations for all the devices which you can find in the CrowPi 1 in this case. So there is already example code here available. And I use some of that to build some other examples. We will come back to that later. But first things first, blinking a LED. The hello world of electronics programming is blinking a LED. I've done that before, but I have now an example with an RGB LED, so red, green, and blue. So you have the three colors in one board, in one PCB. Let me go to the code. And I'm actually using JBang for these examples. So I have created a whole JBang project on GitHub with examples. And let me go to the RGB LED. So for people who don't know JBang is actually a tool to run single or multi-file Java applications with dependencies. So since Java, I cannot even remember which one, you can just run Java with your Java file without the need to compile it. But if you need dependencies, then normally you need a full Maven or a Gradle project. Thanks to JBang, you can do that in one file. So what you see here is a JBang file. It's actually just a Java file. It has this as the first line. That's needed for JBang so that it understands what it needs to do with the file. In this case, I tell it that I want to use Java 25, so even JBang will install Java 25 for you if you didn't do that before. Because Py4j, the library, is still in snapshot version, so it was not released yet, I need this line. So as soon as Java Py4j 4 is released, this line can be removed and the snapshot can be removed. So this is the Gradle style of defining a dependency. So artifact ID and or group ID, artifact ID, and the version. And then the rest, everything below this is the Java code that we are used to. So we have the imports. Again, this is the Java 25 way of doing it. So no class, no static void, public, private, string array args. So we all don't need that anymore. We can just call void main. And what you see then is here the Py4j code. So we have new auto context. What this does is it loads all the plugins that it can find. So here we defined the core library and the plugin FFM. So it will see that it has the FFM plugin, so it will initialize it. And then we can have some objects. Java, object-oriented language. So everything which is an electronic component becomes an object. So we have a LED red color, green color, blue color. So they are of the type digital output. So we want to send something, put it on and off. And we have to give it, the BCM is actually the pin where it is connected. So in these examples, it is connected to the number 23, 24, 25. If you want to know how this numbering comes, where you can find it back, I suggest you buy my book and then you can find this very nice table. Of course, you can also find this online. Now, as soon as we have initialized these LEDs, they are a Java object. So we can do whatever we want and we're used to do with Java objects and call their methods. So an output has a method low and high. So put it low or high. We have some helper functions here to blink it. So for the blink, it's just toggling it 10 times with a sleep in between. So we have some more. This is actually a fun story I shared before my DevOps talk about this topic. I shared the video of this blinking LED and someone says, yeah, if this is the Hello World version in electronics, then it should Morse output Hello World through a LED. So actually someone, Jonathan Stronghorst, contributed that to my code. And this is actually Hello World in Morse, and the LED can blink that. By the way, because of this pull request by Jonathan, he got blocked from GitHub because he referenced which methods, which websites he used to generate this code, and apparently for GitHub that was considered as some kind of attack. I don't know, but we managed to get his GitHub account back within 1 hour. But contributing to Py4j can cause you to disappear from GitHub, apparently. Okay, let me try to show you this. So what you see here is the screen of my CrowPy that you can see behind me here on the camera. Oh, my camera disappeared. Let me add it again. One moment. Okay, now you see it. So this is the camera with the CrowPy behind me. And this is, so the LED, by the way, is here at the bottom. And you see that it's connected with these wires like I showed you on the picture before. And this is my, so this is the screen of that Raspberry Pi. I have on this Raspberry Pi, I have Visual Studio Code. So you can run Visual Studio Code with Java plugins and the JBank plugin on the Raspberry Pi. So that means that you have this programming interface. It's now a very small screen. It's only this screen, but if you attach a full HD screen, you have a full HD interface. So you can have this full experience as a developer. You see, this is recognized as a JBank script by the plugin in Visual Studio Code. So if I execute this, then you see at the bottom that it starts generating this code. And now you see first the red, then the green LED just blink 10 times. And now we should have that Hello World in Morse in red. I don't know if anyone following this presentation who knows Morse, but According to chat models, this is the correct implementation and this is the correct way how it should blink. I have other examples, like for instance, if you go back to the code, this distance sensor is actually using an output pin and an input pin. And what it does is to measure the distance. Can I show you the video again? So these two eyes that you see here is actually a distance sensor, and it works the same way as a bat flies in the dark. So it sends a signal, an audio signal in one end, and it captures how long it takes before it arrives. So you can actually use that to calculate how long it happens. So the output pin, you have to trigger it here. You have to set it high for a very short time and then measure how long it takes before it changes the other pin. So quite some calculations here, but you actually get a nanotime of how long the sound had to travel to arrive back and on the device. So let me try that again. Where is my code? Here is my code. So distance sensor. So if I just start this, then you see it now measures something about 18 centimeters, and that's the distance to the camera in front of it. If I put my hand, I know sometimes this code stops, so let me run it again. Okay, we have a failing demo. We should have a failing demo in every presentation. We also had one yesterday. So this is the one. For some reason, this script stops from time to time, and also always during a presentation. Okay, good. Next thing. Oh, too fast. So these two examples I've shown you. You have seen the results. So here is a video of the results. A video is always something which works. So you see here when moving my hand, then you see that the distance is measured. So apparently without a hand, the distance between my desk and the ceiling, it differs a bit depending on what's happening above it. So reusing that same implementation that already existed, I implemented something with Vaadin. I hope you all know Vaadin. So Vaadin is a tool to create user interfaces. Let me just go to the website. So it's a tool to build web user interfaces in pure Java. So you can build this kind of things with pure Java code. Really love it. And I created something which is based on this Vaadin to interact with the Pi4j. So it's a full application you can find again on GitHub. And let me close a few tabs. In preparation of my talk for DevVox, I had a live stream with Matti from the Vaadin team, and we actually bumped this whole project from Java 21 to 25, a newer Vaadin version. He created a Vaadin component for it, so it was really fun to do this. And I have even now, since 2 days, a pull request from him to improve this project even further. So I will review it and merge it as soon as possible. So again, all the sources of this project are available. Let me show you what's happening. So to make it easy for others to reuse it for other demos, if you want to do that, I separated everything, and this was actually an idea of Matti. So all the backend code is in different classes here, so that you can really see how each of these works. So for instance, you have a touch sensor on that device. So the touch sensor again is an input. Here you can see that there is some extra config that is used. And when the touch changes state, so when the button is toggled, something is published. So this has an impact on the UI. So the UI is here in separate components. So if we go to the touch view, then we see on message when there is, when there is a touch event, then we say that the touch sensor is pressed. So we change something in the UI based on this interface. So this whole application exists on GitHub, is available there to test it. So let's go back to the Raspberry Pi. So I don't need this anymore. So I have here a script to start my application. So Vaden runs within a Spring application, so you should recognize this logging. Okay, it has started, it is available. And how are we gonna demo this? So let me go to Pi4j. So here is the interface, and where is my camera? Here is my camera. Okay, good. So some basic info. So this is running on a Raspberry Pi 5. It has a Linux operating system, of course. It's a 64-bit system, of course, because we have all 64-bit systems now. For some strange reason, this is Zulu running, don't know why. And then we see which plugins are loaded. So it's all FFM based. Other examples, older examples, if you find older examples, older recordings of me, then you will see that this is probably Linux FS or another provider, but now we switch to the FFM plugin and the FFM provider, so everything here. And we see that we have an I2C LCD configured. We have a LED, we have a touch, we have PWM and some other. And now we can actually go look into the interface. And you see that, by the way, Vaden is fully responsive. So if I make this a bit smaller, things start happening. So you see the red LED at the bottom here, that I can turn it on and off from my UI. The touch, so the touch is actually, where is it located? It's here, but if I go move over it and something happens, let me show it. So you see we have this one-on-one direct reaction between the device and the user interface. The LCD display, it changed to hello world. So if I say here J champions conf, then you see that the one row changed. I have a 7-segment display here, so I can put numbers on there. I can put whatever is defined here on that display. And I have this temperature measurement, so that's this black box here that's actually measuring the temperature and the humidity. And if I put my finger on there, you see I have sweaty fingers, the humidity goes up. Now as you can see, this address is actually tunneled. So if you want to join, then please go to pi4j.ngrok.dev. This should now be accessible for everyone of you who is watching this stream live. I will not keep this running after the presentation, but if you join there, and let me put back the camera on the screen. So if someone goes to the web interface and changes, for instance, the text on the LCD display, then we will see it happening here. And the same thing goes for the LCD, the 7-segment display and stuff like that. So, so you see that with all the codes that we know, the way of working with Java, like Spring, Vaden, hello Frank, someone is putting that there. So let me see, I can even get on my side feedback of what people are putting on the display. So if I go back here and someone updates the text, then I will see it happening also in my UI. So there is this whole two-way communication between all these devices. This is fun. You've seen, I had my hands on the, on the camera, so it was not me who did this. Francois, thank you. So everything is happening now through these tunnels. And I can even show you that. So This is running on a Raspberry Pi 5 it was. So this is a quad-core ARM processor running at 2 point something gigahertz. It has 16 gigabytes of memory, but if you look, then it's only using 1.7 gigs of that 16 of memory, and the CPUs are hardly used. So what you see here is that we can actually test everything that we use in production on a Raspberry Pi, which costs between, I don't think, well, between 40 and 100 euros. And actually, some of these are more performant than the basic cloud instances. So if you take the cheapest Amazon or Azure instance, then they are actually a lot more expensive per year than a Raspberry Pi, but they are not so performant. So if you're looking into, I want to test something on an ARM processor, I want to test something on a RISC-V, I want to have some kind of private cloud where I can test Java applications, then even if you don't use Pi4j and interact with these electronic components, this is a very powerful device. And that's also the reason why I want in 2026 test more of these boards, because they come in quite some price ranges, but all below 150 euros. With quite some powerful processors. I have a RISC-V board here, which has 8 cores. Not so powerful as an ARM at this moment, but we'll see. This is always the fun thing when I do this. So now people are trying emojis. And as you can see, it's probably not what you expected. But I love this. I've done this kind of demo at conferences with over 200 people in the room, all trying to break the system. Of course, some managed to do that. But you can see that this is really a powerful combination and a very fun combination. I'll read it run for a bit. We'll see what happens.
Frank, what was the URL again? It was pi4j.
Yeah, pi4j.ngrok.dev.
.dev. Okay.
By the way, ngrok, for people who are like me, don't like setting up tunnels and configuring nginx and all that kind of stuff and routers. And ngrok is really powerful, and it actually turns it around. So the device itself makes sure that there is a tunnel. And by the way, you can see it here. So this is actually what's happening through this ngrok tunnel. So you see that I have 14, 17 open connections at this moment. So I have gone up to over hundreds of connections during earlier demos, and this acts and behaves really powerful. So fun way. Okay, where are we? Oh, at the end. And the timing. Oh, perfect. Thank you. So what's next? I invite you to follow me on socials. Also on YouTube, I have quite some videos, podcasts and stuff like that. All at hashtag Frank Del Porte. Call it at Frank Del Porte, yes. Only on GitHub, I'm F Del Porte. Java on Raspberry Pi is one of the hashtags I use. All the links are on WebTechie. Also, future experiments will be there. You can visit fuj.io and pi4j.com. So fuj.io, all kinds of blog posts about Java, runtime, developer tools, that kind of stuff. And pi4j wants to be the entry point for everyone who wants to start with Java on a Raspberry Pi or similar boards. If you're interested in the code, start and follow github.com/pi4j. And of course, you can already try this Pi4j snapshot with the GBank project that I showed you, with all these different small examples to interact with LEDs, buttons, but even goes further, like putting the weather forecast on a little screen like that, like 2 rows with 16 characters. And of course, if you want to follow the evolutions in OpenJDK and Java, then follow the OpenJDK projects and JEPs. and check out what the architects are really doing with the Java runtime and the language that we all love and want to see what's happening in the future. Okay, that's it for me.
Okay, awesome. So that was great. For years I've been wanting to get a Raspberry Pi, but seeing this what is it called?
Electronics, and but
Yeah.
the fun thing was during COVID, with all the chip shortages and all that we had, is a lot of people had already Raspberry Pis somewhere in a drawer, not using them. And at some point, it was impossible to get new ones, and the prices went up ridiculously on Amazon and eBay, where you could buy them second hand. So at that time, if you had the Raspberry Pi and were not using it, then you had a piece of gold that was laying there. But now they are more easy to get again. And they are Linux PCs. So you can do anything with it. I've written my book on a Raspberry Pi 4 with Visual Studio Code as my editor for my, it's in Markdown format. So it's not so performant, of course, as the latest Mac or Linux or Windows computer, but it's a real powerful thing. And you can use it as any Linux computer, as any Linux system.
Cool. Well, we have, I know we're 10:01 at the moment, but a couple of, I think this one from Francois has to do, is if it's open source too. If so, we can change it. And I think that had something to do with JNI.
JNI itself has been part of JDK itself, and then JNA and JNR are libraries, open source libraries. But actually, everything which is now FFM is part of OpenJDK. So yes, it's open source. OpenJDK is open source. Py4j is also. So if that was what he was referring to, then yes, everything is open source. You can see everything, how it works, and try to improve it or just understand how it works.
So Francois always said that you're a wizard. Confirmed, because he was going to ask about how fast the FFM is. But
I'm not a wizard here. Nick, who built this FFM plugin into Py4j, making these performance tests was part of his development. So within the pull request, he came up with the results. GraalVM, I'm not a fan of GraalVM. I love Java of what it can do at runtime. It can adapt its native compilations of the Java code according to how it's used at that time of the day. So if you have a complex application handling orders, and tomorrow you have a sale and orders are handled in a different way, it will adapt the native code. And that's something which is only possible with the JIT compiler, the normal runtime. With GraalVM, you lose that capability because you don't have the original Java class files anymore. On the other hand, I understand why you would use GraalVM in specific cases where you want very fast startup. On the other hand, improvements are ongoing in OpenJDK to make that possible. Azul also has runtimes which can do that already with Crack and other things. GraalVM is good if you want a very small application, very low memory footprint with fast startup, but you have a whole complexity added to make sure that you can do all the same things that you can do with Java. And I'm not sure if FFM is there. I'm not sure. I cannot answer this question. I tried Graal a few times on Raspberry Pis because I get this kind of questions quite often. I never managed to compile it, but it's some years ago, because at that time I didn't have a Raspberry Pi with enough memory, because compiling with GraalVM into a native application required more than 8 gigs of memory, and I didn't have that. So that's where I got stuck. So I cannot answer the question, but I'm not even sure if I want to.
I guess my first thought was, since it's not Oh, it is finalized. Yeah, it was finalized in JDK 22.
At
Yeah,
22,
okay,
so
sorry.
it probably should be, yeah,
Yeah,
yeah, yeah, yeah.
yeah. And then let's see. So it was a comment Francois had about how you go the extra mile, and then later on he even said that you had the video backup.
But I guided a few students during their final work for school and always said, make sure you have a recording of every demo.
Yeah.
I don't have it of every demo, but the few I did, because I'm not, if I do this at conferences, I'm never sure if I will get online, and I need SSH access to be able to do this kind of demos. At home, I'm quite comfortable, but at conferences, this tend to fail.
And let's see, Francois asked about if special characters can work on your device there.
Well, actually, Francois, this is an open source project. You can find the sources on GitHub, and actually, each of these characters has a drawing. And let me see if I can find this back. Probably not immediately, but actually, for each of these characters, you need to define a drawing. So in which you say, if you select the A, then you have to put on these little lights within these segments or within this display. So it's actually just a matter of contributing that. And then indeed you can add special characters. So I also have demos for this 8x8 LED matrix. I only implemented A to G, for instance, the letters, the characters, and then someone contributed all the others. So yes, this happens with projects like this. if you use it for demos at conference, that people ask these questions, and then I have to challenge them. So Francois, I'm really looking forward to your contribution.
And the reason I interjected and asked about the URL for the demos, Andre actually meant the URL to the presentation, not the.
The presentation itself is not really online because you need all this this extra info around it. But if you go to my website webtechy.be,
okay,
there you can find all the links. Like all the JEPs are there, all the code is there. And here are the codes somewhere. Here. These are the code examples that I've showed you, like this one, native calls. This one is actually the one with that string length method, for instance. So they are all there on my website.
Okay, I think that is it. There were a lot of folks who said thanks for your talk, and I see there's 11 people who have hung with us
until now.
7 minutes over.
So they're missing the next session. So
yes,
that's
which, by the way, is Ken Cousin talking about multiple agents. So, excuse me. This is my last session that I am moderating. So. It's been fun, that much I will say, and interacting with Francois and Vincent and so many other folks over these past 4 days now. So with that, thank you very much, and we'll see you the rest of the day today.
Okay, thank you for having me.